Okay, this is a quick walkthrough of a visualization of the formula that Simon Nubstall used in his video animating a triangle wave in Fusion. This is in a program called LabView, which is a visual programming environment used for simulating systems and controlling test equipment and instrumentation. So there's some text here that explains what the formula is doing. Essentially, we feed the frames in, which is in this case I've taken 480 frames, 24 frames per second, and each frame is stepped through, and this mathematical operation happens. So it works the frequency out from the frame rate and the beats per minute. The frame number is fed in, and it goes through this scaling. And then we take the modulo. And what the modulo does is produces this ramp. There's an explanation there of how it does it. So this is a ramp that goes from 0 to 6 and a bit, 0 to 6 and a bit, which repeats. The red trace in the lower graph is the same modulo, but it's been made bipolar. That is, it's going positive and negative. In this case, going equally positive and negative. So the important thing here is that it passes through 0 and is equally positive and negative. The next thing that happens to it is the absolute value is taken. And what the absolute value does is it takes any negative values and just makes them positive. So at this point, the red trace is at minus 0.4. So the modulo just strips off the minus sign and makes it plus 0.4. It doesn't make positive values negative, it only makes negative values positive. In electronics terms, it's sort of rectified it. So what you end up with is a waveform that instead of going, in this case, plus or minus 1, it goes 0 to 1 and moves backwards and forwards, forming this triangle. The blue trace here is the actual output, and all that is a scaled, shifted version of this. So if we change the offset, we can see that we're moving this up and down. So now it's going 0 to 4. Whereas if we have an offset of 2, it's now minus 2 to plus 2. And if we always wanted it centered around 0, if for instance we had 6, we'd change the offset to 3. So that's a quick visualization of a formula in Simon's excellent video.